Alright guys, good evening. Let's go ahead and get started. So, agenda-wise today, I have a small topic first on exception handling, followed by collections. Collections topic is going to take you through basically data structures in Java. And so first I'm going to take a more theoretical approach in covering collections. In that I'll cover all the algorithms and how those algorithms work. We will also talk about generics, which is another construct in object-oriented design that you need to know to work with collection. And then finally, we're going to talk about how to choose a collection and then get into the collections API. And then we'll talk about assignment 9, which will most likely be your last assignment. So, exception handling. We've talked a little bit about exception handling when we dealt with file I/O. You're sort of required to use exception handling when you're doing file I/O. So my main goal is to give a basic introduction. Nothing that, if you choose to implement this in Lab 9, some part of exception handling, that will be a good idea. But in your advanced Java course, definitely there will be a lot that we will be looking at from exception handling perspective. So please pay close attention. So exception handling is a feature of a Java language that, like any other language, it allows you to intercept an event if something goes wrong. So you can have problems in software that either occur at compile time or can occur in runtime. Compile time issues are easy. You'll get a compiler error, you'll fix the issue. If there is, from a programmatic perspective, you know what can go wrong in software, you can usually use an if statement or some preventive mechanisms to prevent the thing from happening. Like, if you're expecting only 10 values that you should read in an array, and you can write an if statement and avoid an array index out of bound exceptions with an if statement. But if problems occur in runtime that are beyond your control, see, null pointer exceptions, array index out of bound exceptions that you are now familiar with, right? Null pointer exception is when you try and access an object that doesn't exist. Array index out of bound exceptions is if you try and access an index value that is beyond the length of the array. So the point is that if there are things that are out of your control, that are runtime exceptions, right? That's when exception handling really comes into play. Often you're asked this question, when would you use decision-making constructs over exception handling? So it really is a point of saying when I know the issue. If I know the issue at compile time, I will use decision-making constructs. If I know the issue occurrence at runtime, then I will use exception handling. What type of problems can you find in runtime? You get a simple example that I try and show here is numerator and denominator. You're trying to avoid a divide by zero issue. You get the input from a user and you try to divide by zero, that becomes a runtime exception. If you're trying to figure out the square root of a negative number, right? So yes, you can do a validation, but let's say you forgot to do the validation. That is going to throw, that should throw a runtime exception. Problems that you guys have dealt with, let's say you have an array that you declared with will only have 40 records. And you're fed a file that is 42 records. And you don't know at the time, if the goal is that you read one line and populate the object, and you do that row wise, right? Then you can deal with a runtime exception if you hit the 41st row. That's one usage of runtime exception. So citing all these examples and differences between exception handling and issues between compile time and runtime, we get this definition that it's an event which occurs during the execution of a program that would disrupt the normal flow of instructions. If and when that happens, you simply transfer the control to special exception handling code that is designed in a program if an exceptional condition occurs. Let's think about that for a minute. If you try to read a file and the file does not exist in the system, that disrupts the normal course of the flow of the program. So what you can do at that point is have a catch block and print a nice message saying what? File not found. Rather than saying file not found exception, right? The idea is to pay attention to the user experience and give user-friendly messages and not cryptic messages. Good software design always is that. So why do we, yes, we can use if statements, but here are some additional reasons why exception handling code is required. You can separate the error handling code from regular code. And you can have these catch blocks, right? And in advanced Java, you will see how we separate out the error handling code from the regular code. If there are problems occurring in software, we also deal with the notion of self-healing software. In fact, you're taught that and you're asked to implement that. So programs that can recover by itself. Gmail is a perfect example. You disable your network card, Gmail will still run in offline mode. And it will continue to try to enable the chat or continue to try to bring the newest messages with a defined frequency of retry that is usually 30 seconds, a minute, and 5 minutes, and so on. So those are patterns of self-healing software that emerge with exception handling. Because if something goes wrong, you take a note of it, and then on a separate stack, you have some code that executes to retry getting the program back to the normal state, as shown by the Gmail example, right? That is not hard thing to implement, right? You have to think clearly about it. So the point is that you have this two-step process that you have to go through. First, you need to understand the difference between compile time exceptions and runtime exceptions, right? And then when you deal with runtime exceptions, then you have to say what type of this exception is. Does JVM know about it, or does JVM not know about it? If JVM knows about it, it's called a checked exception. If JVM does not know about it, then you have to write your own exception code. Those are called unchecked exceptions. So just so we can kind of make a note of it, right? So I'm going to go back to life, right? Problems happen in life. some that we are aware of, right? And some that happen that we are not aware of. The problems that we are aware of that happen in our runtime. What is our runtime? We are basically executing a program, right? And that we are aware of are checked exception. That means these are the problems I've dealt with before in my life. I've dealt with a failure of some sort. I know what to do if that failure happens again, right? Same with checked exception, JVM knows about these errors. So like file IO, right? In case of a checked exception, JVM is going to require you to use a try catch. That's the sign that, yes, I know about that exception. When a certain event occurs, I know what exception to throw. I still may not know how to solve that problem, but at least I know how to flag that problem. Therefore, I require the usage of a try catch. Now, if I'm not aware of those problems, and those, there are problems that are new, like I'm teaching a new class and I'm going across a content and a question comes up from the class audience that I haven't thought of. That would be an unchecked exception. Now, what do I do when that problem occurs or when that exception occurs? In that case, what I'm going to do is have a custom exception. So I'll just create a box in which, and I'll bring that with me to class every time. And I'll say, okay, in event, there is a question that comes up that I'm not aware of, this unchecked exception, I'm going to take that question and put it in the box. Then I'm going to take a look at it later. And I'm going to say, no, not yet. I'm going to say, it breaks the train of thought. So give me about 20 minutes, right? All your questions I know will get answered. And if you have a question so you don't forget, kindly write it down. Because I know it's easy to forget those, right? So if I put the question in a box and that becomes an unchecked exception, I can go back and later on look at it and say, okay, these are the 20 problems I came up with that I need to go back to the class and address. So in coding perspective, that is done by creating a custom exception handler. That's the box I'm talking about. I'm going to show you a small example of how that is done in this course, but in the 35B, the Advanced Java course, you'll end up creating a custom exception handler, and you'll also end up going through the notion of creating self-healing software. So if Gmail is offline, you can say, how do I bring it back on? By these continuous retrials, okay? It's a really cool thing. If software was written so it was self-healing, right? And you put so much work in exception handling, your code will probably never get released. Because the amount of code that is written for error correction or exception correction can be tenfold of the actual functionality. So you obviously can realize your code will never get shipped, right? So instead what we do is, when we write a custom exception handler, we build the ability of what? Capturing the issues. Just like I was saying, 20 questions come up, I don't know the answers, I'm going to put those in a box. Meaning I'm going to make a note of it. Then I'm going to look at the issues that are being captured, and over a period of time as the program runs, I'm going to look at it once a week and say what are the top 3 issues that are exceptions. So if I am the author of Gmail backend or some code that is being written in Java, Salesforce, right? It's a very complex piece of software. So I can proactively look at the top 3 issues every week and say, why are these exceptions coming up, right? And I can also say what parts of the code, because I know which part of the code is executing. And then I can log those as bugs, and I can have a proactive approach in solving software quality issues. That's how cool exception handling can be. If if you put the hooks in the right place, right, it can become a fabulous thing. So now how is the question, right? That's where you need to come and take advanced Java so you can learn this, right? It's the sales pitch for advanced Java, but the reality is that I cannot cover all that content in this course considering the syllabus, which is our contract. When problems occur, if I am handling every problem myself with if statements, then I'm dealing with those if statements, right? With exception handling, I can pass the buck to somebody else, the calling program. So just like there are roles and responsibilities that team members have. So in a very well-designed, object-oriented team, everybody has roles and responsibilities. Now, if there is an exception that is in your area, you're going to handle it, right? If there is an exception that is not in your area, what are you going to do? Pass it to the team member that should fix those issues. Because one of the nice way of being a spaghetti team member is in a large corporate environment that you say, any problem that comes my way, I will solve. The other approach, object-oriented approach, is what? I will only solve problems that are in my rectangle, in my realm of responsibility first. Then, if I have time, I will, with permission, help others. Make sense? The world, like our physical world correlation to this. So when we talk about propagating errors up in the call stack, that basically means what? That if the exception that just occurred is my responsibility, I'll deal with it. If it ain't, I'm going to push it up the chain so it can be dealt with by the responsible class or the responsible party. So then the last thing is grouping error types and error differentiation. So oftentimes, and I guess you guys have some experience with this, that you're in Lab 8, you're trying to group objects and enable interaction between different packages. You've got the student package, you've got the, what is this other package? Util package, and you're writing this class and you're making APIs and you're creating these packages, right? So now the last bullet point means is that if I go and look at the student package and there are exceptions that occur, I'll give error numbers. Error 1 to error 50 would be in the student package. Error 51 to 100 are in the util package, right? So what happens by giving these exception numbers is that we can trace things like we do in McDonald's. Because McDonald's, how do you get optimization, performance? I'll take number 1 with large fries and large Coke. In fact, they don't even say that. They have an interface. They say number 1 with super package. And now think about this. If you think of McDonald's and you think of performance in fast food, this takes fast food to the next level. I remember buying food from McDonald's in 1988, in 1998, in 2008, and then in 2018 is the next time I'm going to go to McDonald's. The reason I go after every 10 years is because I want to look at their performance. What is the innovation? What is the evolution in the performance of the fast food in 10 years? And what they did was before they would just say Big Mac and large fries. Then they say number 1 with large fries. Then 10 years later they come up with number 1 with super package. Now, a super package means extra large Coke, extra large fries, and you can request Diet Coke with extra large fries and a Big Mac, because you're diet conscious, so therefore you're getting Diet Coke, right? The point is that you are able to order a bunch of things by using numbers, and the performance of checkout is addressed in every McDonald's, right? So now, why the heck are we talking about McDonald's when you're talking about exception handling? Grouping these error types. If you know error 13 occurred in student class and you're the developer, you know which part of the method to go to. See, today you're writing code that is maybe 100, 200, maybe 300 lines of code. right? You take advanced Java, you'll write about 1,000 lines of code. Then you go to Salesforce or Yahoo or Google, you guys are going to be writing tens of thousands of lines of code. Now, how do you find problems that are reported in a bug? Well, you have now, just like McDonald's, said problem number 3. And maybe you can say problem number 3 with super large thing. Then you know which method to go and fix things in, right? Now, not only that, are you the person doing the testing? A software engineer, yes, is doing the testing, but if you are a QA engineer, guess what? You are testing exceptions, right? If you are testing error number 3 and trying to figure out all the things to make sure that error 3 never happens, it becomes a good communication between what? It becomes an interface between the QA team and the development team. This is again the reality of good software quality deliverables, that the interaction between the quality team, the QA team, and the development team. And QA engineers would really like if you put these hooks in place, and it's done again with exception handling with grouping types. I hope my examples are helping you understand from a semantics perspective how this would work. I don't care about you guys understanding the coding perspective of exception handling. If you're dangerous with it in this course, that's fine. You at least know the minimum, try, catch, finally, we're done. And then you know all these semantics, we are in like great shape. You get in 35B, then we start drilling on what? Implementation. In context of a larger application that you can show off to your hiring manager that I wrote this really cool thing, and these are all the cool things I learned. So, runtime exceptions. Pointers. Not Java pointers. There's no such thing. References, right? Null pointers. Indexing exceptions. We already talked about this, so we're not going to. So this is what the try block looks like. Why do we use a try block? For a checked exception. You're trying to open a file, try block. Right? And it can have one or more statements. The principle of try is what? Let's just go ahead and try. And every code block should be like that. Because in reality, there is nothing firm that we know will always work. So it's always good to try. So exception handling is that. So when one of those statements fails, what happens? The control goes into the catch block. So these are some things that we do about the try block. Each statement that throws exceptions can have its own try block. So imagine if you were writing some super defensive code, every line of code will be in its own try block, and it will have its own catch. And one statement can lead to 3 exceptions. When you start coding like that, that's when your code never gets released, because you're in this paranoia of fixing every possible issue before you will deal with shipping the code, right? Or you can have multiple exceptions. Throwing statements can be put in one single try block, which is again what we have done with file IO, right? Or the previous assignment. Exception handlers must be placed immediately following the try block. That's the catch block. So if any one of those exceptions occurs, you can have a nice catch block. And a try block must be accompanied by at least one catch block or one finally block. Finally block is created and it is always executed, regardless of whether an exception occurs or not. So we're going to see some examples so you can understand the behavior of try, catch, finally. Okay, these are the 3 main constructs I need you guys to know. So this is the syntax for the catch block. Catch block is typically you pass a formal parameter of an exception and you can have a bunch of these catch statements. You want to be careful when you put a bunch of catch statements for one try that you don't put the superclass of all exceptions as the top one. then the rest of the code becomes unreachable. You want to put the child class on the very top, and then the exception class, which is the bottom. Exception class is a superclass of all exceptions. There is an example that will show up in this row. So the argument is the type of exception object, like a method declaration, and then within the code here you can try and provide some mechanism to sympathize with the issue. Sorry, the program crashed. Try again, right? Which is all most healing is sympathizing. So, meaning printing what the error is. Finally, block provides a mechanism that allows the stack to clean up after itself, regardless of what happens in the try block. So if you want to clear the stack, right, you can set certain objects to null before you go back and retry. So that's done in the finally clause. Finally clause can be used for closing files or releasing the system resources. So here is the first example. I do have these in soft format. So we have a main, and we try to divide by 0, which can throw an arithmetic exception. And then we can say divide by 0 exception just occurred. Right? If I was dealing with an array in the try block, I could have another catch block following this part of the code, and I could say catch array index out of bound exception. If I come across an array element that doesn't exist, and if you try and access that in the try block. So these are, if I don't do it, if I don't have a catch block for an exception, then basically that will be passed and it will be thrown, the actual exception message will be thrown into the console. It will be thrown into the output screen, which is something we don't want because that's considered unfriendly. Like if I go to a website and it says super administrator password for the database needs to be reset, that looks really bad because it's exposing the internals of my system. I want to mask as much as possible. Finally, it just shows you what? That statement is always executed. You guys should probably try and run these small programs. I have a soft copy of these, so you should consider running these just to see how things work. I'm also going to throw an example of custom exception. How do you end up writing a custom exception? But before I go through this, I put the questions on hold, and I can take your questions now if you'd like. Please. When
we were first doing the exceptions, like exceptions that the computer knows exist, and then exceptions that the computer doesn't know exist. So any exception that the computer doesn't know that exists, does it just have one thing for all exceptions that it's not aware of go over here?
Yes.
Then how do you mark each thing as a different thing? Each error is a different error.
Okay, so the way to mark every exception, you create a custom exception. And you can launch an instance of the custom exception with a number. So like you can have an instance variable in that custom exception class like error number. Mm-hmm. And if you are in a certain situation in the code, in an if statement, you can instantiate that custom exception object. When you do that, you can also, in the custom exception class, write some code. So when we are doing file I/O, right, you can log those exceptions and append more to a log file. So that way, that's how you can have a running log of issues that might occur or as your code is progressing. Granted, you may not be able to solve all the issues, but at least knowing that those issues are occurring becomes a starting point for preventive measures. If you don't know what the problems are, we can't solve them. But so we start logging the issues through custom exception. And that's something I will cover in the advanced Java course. Yes, please.
You were mentioning that it's possible to, just throw catch and try in each piece of code that we create.
Mm-hmm.
But how do we know which one is more important to throw that try and catch and leave the rest just, execute themselves?
So the question is, how do you identify which problems are more important than others?
That you need to put that try and catch in there.
Right. That's in the eye of the beholder. Because the complexity of an issue can either be determined by its frequency of occurrence. If a problem is if an exception number 35, you put it in 5 different places in the code and it's the one that is occurring the most number of times and has a consequence of it has some impact in the client's experience, right? So that then becomes a function of design, customer impact, number of times it's occurring, and if let's say if it causes data corruption or a potential of data corruption, it hasn't occurred yet. Those kinds of things you can you deal with being a designer of that software.
Are we going to tackle throws?
Throw and throws will be tackled in the next course.
Even throwable?
Yes, right. This is just a gentle introduction. Right? So you have the foundation, but then there's so much more. Obviously, in exception handling that, as based on the questions you're asking. So. Yes.
So for the example you had above, the soft code you had right there, so when it does the try catch and it tries to divide by 0, it'll print divide by 0 exception. But since it's in a for loop, would it still continue?
No.
No? So it'll stop right there at 0?
When this problem occurs, it's going to stop here,
Okay.
and the control will go here.
Okay.
Then it will execute the finally clause,
Okay.
and it will exit.
Alright.
Continuation to this question. Like we did the input, right? So people enter input, like we are trying to do that, but we don't want to stop. We want to continue. Give them opportunity.
If state. So in that case, if the user input is invalid, then you can put a loop outside of the try catch. So the catch can print and then you can go and retry. You can do that. And in the finally block, you can clear the value that you have read, so you can go back and retry and train the value. Make sense?
So here, if we want to print counter from 1 to 4, 1 to 3.
If you want to,
Print the other bit. Only divide by 0 will be,
an exception.
yeah.
Right.
And the others will be printed.
Correct.
So how do we do that? Because here it will go and just print divide by 0 exception and it will not move the counter.
Correct.
Right?
Right.
So if we want to implement it still, just ignore divide by 0 and then execute divide by 1 and print the counter as this one.
So just to repeat the question for one recording sake and the rest of you, if you I don't know heard it, she's asking the question that if we want to just ignore I equal to 0, okay, fine, the exception occurred, and we have printed the exception as occurred, and we want to continue on with I equal to 1, right? So in that case, you can put a do while loop outside of this and use a flag, right? So for counter equal to 0, the exception has been raised, it's been noted, then you increment the counter, right? And I will not be declared here, I will need to be in the context of the outer, it will need to be at the scope level of main. So you can put a loop to continue.
It should be for loop, it should be while loop.
It can be any kind of loop. I mean, you can use a for loop for events. So the point is to create an event where you just continue on forward, and that's just the semantics of addressing that issue. code-wise, I think you guys have written enough code with loops that you guys can, tackle. Are there any other questions before I spend a few minutes on custom exceptions? Okay. So custom exception extends the exception class. This is a custom exception handler that we're going to write. And the idea of a custom exception is that I can, for either checked or unchecked exception, create my own exceptions as one bucket. This is where I'm creating my box, right? If file IO occurs, I want to know about that in this box. If there is some other runtime issues that I haven't dealt with yet, I want to know about those in this exception. So I go in and I look at example 2. I thought that was in the slide, but I guess it's not. So okay, so when you click on those, you'll get this custom exception. Okay, that will not work. So let's do this. Can I open this with TextPad, which might be better? Sorry about this, guys. TextPad would have been easier. So custom exception extends exception. And all I have is a simple old constructor that takes in a string to state what type of exception it is, right? This is custom exception handling at its infancy, just starting off, right? So I have this code block. So then the next thing is program 2. Okay, so we have the program tests. We have a program 2 with method test, and it throws custom exception, right? So this throws statement with custom exceptions is important. Because when I'm running program 2, I want to tell the program 2 class to load custom exception in event an exception is raised. So we don't go and import the custom exception. We use the word throws custom exception, and what that means is that, especially with the signature declaration, that when the method test is called, it should flag the Java virtual machine to load custom exception. So I instantiate program 2 and I call the test. The test method, because it throws custom exception, I'm required to use the try catch clause. It becomes a checked exception. So now when I call ptest, right, the only statement I have in that is to instantiate custom exception. Now generally I'll do this under certain condition when I do have a problem. Like what? An if statement. I'll have an if statement which will have a certain condition, and when that condition becomes true, I'm simply going to let the custom exception handler know and say, I want to throw this new exception, right? This is like, you guys are in the class, and if you have a question, right, you raise your hand, right? And that is a flag for me to know that you have a question. Throw new custom exception is the same thing. When you have a question, you're basically creating a custom exception object. Now, in the Java virtual machine environment, there is the exception handling system, right? So what happens is every time an exception is thrown, that disrupts the flow of the program. So if there were other statements after the throw, let's say I have a couple of statements. This is obviously pseudocode. st1, st2, those two Java statements will not get executed, right? The code will get interrupted at this point, and the flow will go into the catch block. And then it's time to remedy that, right? I'm not looking at the internals of how JVM processes exceptions in this course. I do that also in the next course. But the point is that you are throwing exceptions on the stack, and if you end up passing the exception to another method in the call stack, like you keep saying throw new all the way up to main, then the call stack gets really large, right? It's just like escalating a problem that a software engineer has all the way to the VP of the company. Think about the overhead, right? You have a P1 bug that you didn't solve. So then the bug system automatically sends an email to your lead, to your manager, to your director, to your VP, and the CEO. And now the CEO comes to your desk and says, why haven't you solved this exception? Get it? So problems should be solved close to where it occurs, especially if you end up in the realm of objects being self-contained. Self-containment means what? The class solves its own problems, or it notifies another class that throws that exception, so placing the responsibilities in the right place, right? So I hope this gives you an introduction to at least how a custom exception is written. You extend the exception class, you use the throws keyword to load that exception class in event an exception is thrown, and then when a situation occurs where an exception management is warranted, the throw keyword is used. Please note the difference here, throw and throw. The throw keyword is used to instantiate the exception. Your question?
So if you had like statement 1, statement 2 before the throw new catch exception, they would actually run?
Yeah.
So it's only if you put it after that will run?
Right.
Okay.
Just like the try block, right?
Okay.
It's the same story. So this is like the ABCs of exception. You know, to wrap up, let's try something. If something goes wrong, let's catch. If we need to reset something, let's put it in the finally clause, which is always executed. And if there are exceptions that we need to track that are very specific situations in the entire code base, then we can create a custom exception. So we can use that anywhere in the code, right? These are all the semantics, and code-wise, those are two little programs that I would like you to know in preparation for the final. Question?
Yeah, the throws exception, the throw, the new is a custom exception, followed by the actual words of what needs to flow.
Correct.
Can that all be in that class, or can is that the whole new, the custom exception is an extension of the exception, right? So you have to write the class code.
Yes, right here.
So,
This is the class I'm using.
right, the super message is that one, right? That
Correct.
used to be our problem.
So what happens is when I instantiate the exception object, this string Houston we have a problem gets passed into the message, right? And super message means there is an exception message being given to the exception class, which is the API that we use to plug in our custom exception.
So we can have various public custom exceptions?
Oh, yes. Normally you have one, and you go in and you declare an instance variable int1, int I, and string d.
Oh, so you
So-
match that one says this, two says that.
Correct.
Error messages we
Right. If I expect 1,000 potential messages, I'm not going to create 1,000 exception classes, because I don't get paid by the number of exception classes I write. I get paid by one, and I can simply define I and D. And then that one object is a descriptor for different exceptions depending on the situation. So, yes.
Is there anything else you can do besides putting a message for this throw and catch?
Oh yeah, you can fix exceptions.
Oh, so you can have it automatically fix it?
Yes.
How would you do that? Give me an example.
I will see you in 35B.
Oh, so that's like down the road?
Down the road thing.
All right.
So question is, can the exceptions be fixed? Totally.
Yeah,
You
that's-
basically write fix methods, and you can write a lot more code for fixing issues than the code itself. And so yes, we talk about, that's the notion of self-healing software. So where, especially if you go in Gmail or something, you've seen
Yeah.
that.
So just printing something doesn't
Oh no, print is like, I'm sorry there is a problem. And that's what I call sympathizing with the problem. But that's a good start. Acknowledging the problem fixes the problem by 95%, right? Or so our president says. So, and then the 5% is what? Okay, maybe that's a bad political statement, right? But we are acknowledging the issue. And then we say, okay, I'm responsible.
Yeah.
And then after that we fix, if we get to it. Okay. Any other questions? So the difference between throw and throws. Throws is loading the exception, right? It's right here. Throws is simply loading the exception class. If nothing goes wrong with the test method, then that custom exception will never be used. But if something goes wrong, then I throw, singular, right? Then I go in and say, okay, I want to throw this exception. And when I throw the exception, at that point, I have instantiated that object. And then how does this get processed in the JVM? Continuity of code and so on, with custom exceptions we will look at in the advanced course. Any other questions? Okay, so that's everything on exception handling. All right?